A highly active and mysterious underwater volcano off California's coast could erupt before year's end.
Deep beneath the waters of Clear Lake in Northern California, a restless force has stirred again. For decades, the Clear Lake volcanic field has slumbered quietly, its hills and ridges covered in vineyards, forests, and communities that thrive around its serene surface. But the United States Geological Survey has recently revealed that signs of awakening have returned. Signals that the volcano beneath Clear Lake may no longer be as dormant as many assumed. Scientists are watching closely, interpreting tremors, heat flows, and subtle ground movements that suggest magma is shifting deep below. For California, a state already acquainted with seismic hazards, the reanimation of Clear Lake raises both scientific intrigue and public concern. Before we start, smash the like and subscribe buttons for more updates. The Clear Lake volcanic field is no ordinary patch of land. It has a geologic history stretching back over 2 million years, forming through countless eruptions, some small and some violent enough to leave scars across the surrounding valleys. The most recent eruption occurred about 11,000 years ago, relatively recent in geologic terms, which places Clear Lake in the category of an active volcanic field rather than an extinct one. This designation matters because, unlike a dead volcano that has exhausted its magma supply, an active system still holds the potential for future eruptions. What the USGS has now indicated is that activity within the field is showing unmistakable signs of life again, hinting at magma movement that could precede new eruptive behavior. At the heart of this renewed attention lies the detection of seismic swarms, patterns of small earthquakes clustering beneath and around the lake. While these tremors are not large enough to cause direct damage, they are a classic signal of volcanic systems adjusting to internal pressures. Seismic activity reveals the cracking of rock and the pressurization of chambers beneath the surface. Coupled with changes in geothermal systems, hot springs, fumaroles, and increased heat flow, the picture begins to suggest that Clear Lake is not simply resting, but preparing itself for something greater. Scientists are not claiming that an eruption is imminent, but the mere acknowledgement that the system has awakened changes the narrative. The key question becomes whether this is the beginning of a new eruptive cycle or simply another episode of underground stirring that may quiet down in time. Volcanic systems often behave unpredictably, and history shows that they can exhibit heightened activity for decades before any eruption takes place. Yet the signs are compelling enough that researchers must treat them with urgency, balancing scientific caution with the responsibility of keeping nearby communities informed. Clear Lake's volcanic field is unique in its setting. It lies at the northern end of California's active volcanic arc, a chain linked to tectonic processes driven by the complex collision and subduction of plates along the Pacific coast. This chain includes other well-known volcanic giants like Mount Shasta and Lassen Peak. But unlike those towering stratovolcanoes, Clear Lake's activity is spread across a broad volcanic field dotted with smaller vents, domes, and flows. This dispersed structure means eruptions here could emerge in unexpected locations, creating a challenge for prediction and planning. Residents living near the lake or within the surrounding towns could find new vents opening in areas long thought to be geologically stable. The very landscape around Clear Lake tells the story of this past volatility. Layers of basalt, rhyolite, and volcanic ash bear witness to past eruptions that reshape the terrain. Hot springs bubbling at the surface today are reminders of the heat lingering beneath. Communities such as Clear Lake, Lakeport, and smaller settlements have grown accustomed to these geothermal features, often seeing them as part of the area's charm. Yet what once felt like a benign curiosity now holds deeper meaning in light of the USGS findings. Each rising plume of steam or unexpected quake could be interpreted differently, not just as a quirk of geology, but as a whisper of something larger building below. The economic and social implications of this awakening are profound. Clear Lake and its surrounding region form part of California's wine country, attracting tourists, supporting agriculture, and sustaining livelihoods. The vineyards and orchards that carpet the slopes are nourished by volcanic soils, which are rich in minerals. However, the very source of that fertility, the volcanic activity, also carries the risk of disruption. Should the system progress toward an eruption, even a small one, it could affect not only the physical safety of communities, but also the broader economy tied to the land. For residents, the awakening of the volcanic field creates a new layer of uncertainty in daily life. There is also the psychological impact of living near a restless volcano. Awareness shifts when people are reminded that beneath familiar landscapes lie forces capable of dramatic transformation. For many in Northern California, earthquakes are an accepted part of reality, a background hazard that has shaped building codes and emergency practices. But volcanic eruptions are less familiar and they carry a different kind of dread. Earthquakes strike suddenly and end quickly, while volcanic crises can unfold over weeks, months, or even years, creating long periods of anxiety and watchfulness. Knowing that Clear Lake has awakened places the region in this uncomfortable position of waiting for answers that may take years to clarify. For the scientific community, the reawakening of Clear Lake is also an opportunity. Every stirring volcano is a natural laboratory, offering insights into how magma systems behave and how surface signals can be interpreted. By monitoring seismicity, gas emissions, ground deformation, and geothermal activity, researchers refine the models that might one day allow more precise eruption forecasts. Clear Lake's activity can teach lessons not only for California, but also for volcanic regions across the world. Each tremor and fluctuation adds data to a global effort to understand how volcanoes transition from dormancy to eruption. One of the most intriguing questions raised by this awakening is whether Clear Lake might be preparing for a silent eruption. The term suggests the possibility of an eruption that begins subtly, without the dramatic precursors people often expect. Not all volcanic activity starts with massive explosions or visible lava fountains. Some eruptions emerge as slow effusions of lava or quiet dome-building events, which may initially escape notice. In heavily monitored regions like California, it is unlikely such an eruption would remain entirely undetected, but the concept underscores the diversity of volcanic behaviors. The fear of a silent eruption taps into the unpredictability of these systems, where magma can intrude toward the surface with minimal warning, leaving scientists racing to interpret limited signals in real time. Clear Lake's geothermal features provide hints that magma is indeed influencing the near-surface environment. The region hosts one of the largest geothermal power plants in the world, known as the geysers, which taps the heat generated by volcanic processes beneath the earth. This immense reservoir of heat underscores that the system remains alive and dynamic. Fluctuations in geothermal activity could therefore serve as both an opportunity for scientific monitoring and a challenge if they shift unpredictably. Changes in steam venting, for instance, could mark new movement of magma or the reconfiguration of underground reservoirs, serving as a harbinger of broader change. The timing of this revelation also intersects with broader conversations about natural hazards in California. The state has faced devastating wildfires, ongoing drought, and the looming threat of major earthquakes along the San Andreas Fault. Now, the awakening of Clear Lake adds another layer to this already complex tapestry of risks. It reinforces the need for resilience planning that accounts not only for the hazards people expect, but also for those that remain in the background until suddenly reasserting themselves. The awareness that California must prepare for volcanic hazards, as well as seismic ones, broadens the scope of emergency management and public education. What makes the Clear Lake awakening particularly striking is its reminder that volcanoes need not be towering mountains to pose significant threats. The volcanic field here appears almost ordinary at the surface, its ridges softened by time and covered in vegetation. Yet below lies a magma system capable of reshaping the region. This contrast between appearance and reality makes the revelation unsettling. People often associate volcanic danger with iconic peaks like Mount St. Helens or Kilauea, forgetting that volcanic fields with multiple vents can be equally potent. Clear Lake's resurgence highlights that hazards are not always where people expect them. It is important to emphasize that the current signs do not guarantee an eruption in the near term. Volcanic systems often operate on timelines far beyond human scales. What feels urgent to us may be merely a short pulse in the volcano's long life. Yet that does not diminish the importance of paying attention. Every sign of movement offers a chance to refine understanding, to improve monitoring, and to strengthen preparedness. If the magma beneath Clear Lake is testing the boundaries of its chambers, it is sending signals worth interpreting with care. Communities around Clear Lake now find themselves at the intersection of beauty and danger. living near a lake born of fire that may yet see fire again. The USGS revelation is not a prediction of disaster, but a call to awareness. It invites a deeper appreciation of the forces shaping the land and a recognition that the tranquility of today is not guaranteed forever. The vineyards, forests, and homes that flourish on the lake's edges do so because of the volcanic history that built the soil and the landscape, yet they also exist under the shadow of that same history. The idea of a silent eruption lingers as a compelling possibility, one that forces people to think about what eruption means. It need not always be the catastrophic explosion filling skies with ash. It could be something quieter but still transformative. Lava pushing through cracks, reshaping shorelines, altering water systems, or creating new landforms. The very ambiguity of what might come is what makes this revelation so significant. Living near a volcano is living with uncertainty, where the land itself is an unpredictable partner. As scientists continue to monitor Clear Lake, the broader story is one of vigilance. Each instrument placed around the volcanic field, each seismic reading, each sample of gases from a fumarole contributes to building a clearer picture. This network of observations is humanity's best tool for coexisting with volcanoes, offering not certainty but insight, not guarantees but guidance. Clear Lake's awakening is a reminder that the work of observation is never finished, that even quiet landscapes can surprise us, and that the forces shaping the Earth remain active and powerful. The awakening of California's Clear Lake volcano has reignited both scientific curiosity and public concern. For now, it is a story still unfolding, a narrative written in tremors and steam. What happens next is uncertain, but the implications are vast. The land is speaking again through the language of geology, and it falls to us to listen carefully, to prepare thoughtfully, and to remember that beneath the calm waters of Clear Lake, the fire has never truly gone out. Clear Lake's stirring has ignited not only local concern, but also a broader conversation about the hidden dynamism of Earth's crust. When people think of California's hazards, their minds leap to fault lines like the San Andreas, or to the seasonal cycles of fire and drought. Yet beneath the rolling hills and placid surface of Clear Lake, another force has always waited, and its subtle reawakening broadens the scope of what Californians must remain mindful of. To understand why this moment is so pivotal, it helps to situate Clear Lake within the larger framework of Earth's volcanic systems, where heat, pressure, and chemistry combine to produce the extraordinary phenomenon of eruption. Unlike regions defined by single iconic peaks, volcanic fields like Clear Lake represent distributed systems. Instead of one central conduit feeding a towering mountain, magma here can intrude across a wide area, searching for weaknesses in the crust. This distribution makes volcanic fields deceptive. They appear less dramatic than high stratovolcanoes, but they can be equally dangerous. A future eruption at Clear Lake might not occur in a predictable place, but instead emerge from a fissure or vent that has been dormant for millennia. This unpredictability is one of the most pressing challenges for volcanologists who must anticipate where hazards might arise when magma makes its way upward. Understanding Clear Lake's current stirring requires an appreciation of magma dynamics deep beneath the crust. Magma is not a uniform reservoir of molten rock sitting idly below. It is a constantly shifting mixture of molten material, crystals, and volatile gases. When pressure builds as gases attempt to escape, magma can rise toward the surface, fracturing rock along the way. Each fracture produces seismic signals, tiny earthquakes that scientists detect with sensitive instruments. What makes the recent activity significant is the clustering of these tremors, which indicates that the system is not behaving randomly, but as part of a coordinated shift in pressure. These earthquakes form part of a symphony of signals, each providing clues about what the volcano is doing. Ground deformation is another. When magma pushes upward, it can cause the land to swell subtly, sometimes only by centimeters, detectable only with satellite radar or GPS. At Clear Lake, monitoring equipment is tuned to register such changes, searching for the telltale inflation that might suggest magma is accumulating at shallow depths. Combined with seismic data and heat flow measurements, these observations create a multi-layered portrait of the volcano's state. The lake itself plays a central role in the story. Clear Lake is the largest natural freshwater lake wholly within California, and its waters mask much of the volcanic system's surface evidence. The relationship between water and magma has always been volatile in geologic history. When water infiltrates hot rock or rising magma, it can generate explosive steam-driven eruptions known as phreatic events. These explosions may not involve large amounts of lava but can still be violently disruptive, scattering ash and debris across surrounding landscapes. The presence of Clear Lake above an active volcanic field adds a layer of complexity to predictions, since interactions between magma and the lake could determine the style and intensity of future eruptions. Beyond the lake, the surrounding geothermal features, hot springs, mud pots, fumaroles, are outward expressions of the system's heat. These are more than tourist curiosities. They are dynamic indicators of what lies beneath. Changes in the temperature, chemistry, or distribution of these features can signal shifts in the volcanic plumbing system. For instance, a sudden increase in carbon dioxide emissions could reveal degassing magma. Such subtle signals may precede more obvious signs of volcanic unrest. By studying these features continuously, scientists create a baseline against which anomalies can be recognized, and Clear Lake provides an especially rich environment for such work because of its already active geothermal landscape. The Geysers geothermal field, lying just to the south, ties Clear Lake's volcanic system directly to human industry. For decades, this immense geothermal resource has been tapped for electricity, making it the largest complex of its kind in the world. The fact that humanity has harnessed this volcanic energy underscores how intertwined our lives are with the Earth's hidden processes. But it also raises questions. Could changes in geothermal exploitation affect volcanic dynamics, or vice versa? While most scientists argue that energy extraction does not directly trigger eruptions, the interplay between natural heat reservoirs and industrial use remains an area of careful study. It serves as a reminder that the volcano is not just a natural backdrop, but part of an interconnected system with human activity. Culturally, the awakening of Clear Lake also reverberates through local communities with long histories tied to the land. Indigenous groups, particularly the Pomo people, have lived around Clear Lake for thousands of years and carry oral traditions that speak to the lake's fiery origins. For them, the stirring of the volcano is not simply a scientific event, but part of a living relationship with the landscape. Their traditions recall times when fire and ash reshaped the land, and these stories are often rooted in genuine observations of past geologic events. The blending of cultural memory with modern science enriches the understanding of what Clear Lake's awakening means, reminding us that human beings have been observers of its rhythms long before satellites and seismographs. The implications of this reawakening ripple far beyond the borders of Lake County. California is one of the most densely populated and economically vital regions of the United States, and any volcanic disruption here would have consequences extending across supply chains, travel, and energy systems. Even a modest eruption producing ash could affect air quality and disrupt agriculture, while larger events could impact infrastructure. Although the probability of a large eruption in the near term remains low, even the small chance prompts state and federal agencies to revisit preparedness strategies. Clear Lake's unrest feeds into national assessments of volcanic risk, reminding policymakers that California's threats are not confined to earthquakes. The scientific curiosity surrounding Clear Lake also lies in the potential for it to behave differently from other nearby volcanoes. Whereas Mount Shasta or Lassen Peak have histories of explosive eruptions driven by volatile rich magma, Clear Lake's history shows a combination of explosive and effusive activity. Lava domes, formed when sticky magma piles up near the vent, dot the surrounding landscape. Such eruptions can be slow-moving but still hazardous, creating unstable domes that may collapse and generate dangerous pyroclastic flows. The uncertainty over which eruptive style Clear Lake might adopt in the future complicates forecasting efforts. It forces scientists to prepare for multiple scenarios, from quiet lava outpourings to more violent ash-producing events. Technological advances are making it possible to track these hazards with greater precision than ever before. Remote sensing satellites can map minute changes in elevation across the volcanic field, while drones can sample gases from otherwise inaccessible fumaroles. Machine learning is being applied to seismic data to detect patterns too subtle for human analysts to spot. Clear Lake's awakening provides a proving ground for these innovations. allowing researchers to refine tools that may one day save lives by providing earlier warnings. The field thus becomes not only a local hazard, but a global laboratory contributing to the advancement of volcanology. The notion of a silent eruption resonates particularly strongly with scientists and the public alike because it embodies the fear of what cannot be easily seen or heard. A silent eruption may begin as underground magma intrusion, slowly deforming the land or altering groundwater systems before breaking the surface. They demonstrate the Earth's capacity for gradual yet relentless change, reshaping landscapes in ways that may be profound, yet initially unnoticed. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on Clear Lake awakening? Eruption risk or false alarm? We want to hear from you. Thank you for watching and see you next time.